Hello everyone, it's the AI programmer back at you once again with another video. This time we're going to be kind of breaking down this article here that I found on yekta.dev, which is a blog, which is a developer blog. So huge shout out to the owner of this blog. Make sure you guys check it out. I'll leave it linked up in the description box below, the link to this article so you guys can check it out for yourselves. But without further ado, let's kind of jump into it here. So the title of this article is "Don't Overplan, Do Prototype," and I kind of wanted to go over this article because it very much emphasizes something that I stress as a software engineer, which is, you know, um, rapid prototyping, right? And learning by doing, right? I feel like there's often a lot of you know, people often keep themselves stagnant, especially aspiring software engineers, because one, they think that theory and concepts and reading about these things is what's going to get you to where you need to be, and that's simply not true. It's simply not the case. Regardless of how much you read and how much information you try to assimilate by simply reading, right? Simply absorbing, you know, you have to start putting this stuff into practice to really be able to speak to these things, especially when it comes to being interviewed, right? And answering interview questions. You can practice a million questions and, I guess have memorize responses, right? But if you can't, what if you're asked to expand on that response, right? As far as from the context of a practical example, how can you speak to that if you have no practical example to pull from? Oftentimes, in interviews, I want to say you can get by even if you don't necessarily know the full definition of a theory or a concept, right? Like what is object or oriented programming, right? If you don't necessarily know the full definition because you haven't looked at it in a while, that's fine if you know what object oriented programming entails from a practical standpoint. But like when you're setting up a Java, when you're setting up, I want to say a Spring Boot project, right? You're setting up a Java project and you're setting up, classes and whatnot. Being able to speak to that and say like, well, this is what I'm doing here, all of this, right? And all of these different things and all of these different things together. This is what encompasses object-oriented programming, right? What I'm doing in Java, with this application. And of course, it's an object-oriented programming language, anyways. But just being able to speak to that practically is going to help you a lot. Um, just speaking to the doing, right? They'll be able to say, well, this guy might not know theory and concepts exact, but this guy or girl definitely knows what they're doing and definitely has experience building Java projects, and so on and so forth, right? So let's kind of jump into the article here. Now that I've kind of bored you guys. So overcomplication and overengineering are some of the direct consequences of overplanning. A common trap I've fallen into countless times. This can happen on almost all software projects. It often results in a huge amount of wasted time and energy and an overcomplicated outcome, which is very true. You don't want to spend too much time. Well, let's actually go over something here, which is something you should be utilizing as a software engineer, whether it be personally or in your professional day-to-day life, right? You should be time boxing your activities. And what I mean when I say that is that you should be doing things and have a certain time or duration for how long you're doing them for. You shouldn't be, so if you're working on a specific problem or trying to debug or solve an issue, you should say, I'm going to work on this issue for 30 minutes or an hour, and I'm going to either A, take a break, I'm going to maybe reach out for help if you have a team, I'm going to maybe look on Stack Overflow and do some research, or maybe I'm going to, work on something different. Maybe work on the UI piece, work on the front end, take a break from kind of the back end stuff. So there's lots of things you can do, but these are things that you want to do. You want to time box your activities because you don't want to be working on something for a long time, um, like over planning. So we learn the most when things happen to us. So this is very key. We learn the most from when things happen to us, and that means experience is the best teacher. I'm quite sure we're all familiar with that term or that phrase, and that's the way it always has been. It has always been. We may even hear useful advice directly related to our future situations, but bury it deep in our memories. Then we face the same issues ourselves, forget about the advice, get hit, and become the tellers of the experience for the next generation. Anyway, this is another experience I wish I could share with my younger self. Trying to reach perfection on paper is pure poison. That's a very bold statement. It's something you should remember. Trying to reach perfection on paper is pure poison. Now, as a person who is very dedicated to my penmanship, I kind of disagree with this, but in the context of software engineering, it's somewhat true. Now, I do think that you should look to write more code, you know, because that will definitely improve your understanding. But let's kind of jump into more of the article here. So, table of contents. So, let's jump into the why. So, you don't know what you don't know. So the way you discover what you don't know is to encounter it. So when you dream on paper, things may shift from reality and you may not see the whole picture. True. The wrong bottlenecks may be identified, the wrong solutions proposed, and the wrong problem solved. So when you're conceptually architecting things out, this is exactly true. You know, you might think you're identifying things that maybe these are all potential things until you get into the actual meat and potatoes, which is the code. You everything is all potential. Everything that you kind of laid out is all it's a potential problem, right? This is a potential, you know, route that we can go, right? This is a potential strategy we can take. This is a potential pattern that we can use. So this is a potential tech stack. So just keep that in mind. Everything's until you start actually coding and your project is created. Everything is just potential. So let's continue. You might even address a problem that doesn't exist or is less important than other aspects of the system. Over engineering is a common mistake in this scenario. One way I used to always make. Okay, so this is a mistake they used to always make, over engineering. It's hard to foresee all the challenges in the system you haven't designed. So additionally, overplanning can oftentimes be a shield, a safe zone, or a procrastination technique to avoid being vulnerable to new experiences. It's easy to get lost in the plan. Let me go back to this line here. It says it's hard to foresee all the challenges in the system you haven't designed. So that kind of seems like a contradiction to the main point of this article, which is, I want to say, pushing for more rapid prototyping. But I digress. Maybe I'm just misreading it. So it's easy to get lost in the planning phase because it's a lot more comfortable than the actual work. Very true. And I have a personal story about this, because I've actually, you know, I want to say I have worked on products that have spent months in the planning phase. And while it is nice, I guess, to, in a sense, you know, get paid for, you know, no, I don't really believe in that. I don't want to make that statement because I like to actually do work that's impactful. I don't like to just kind of you know, milk time, right? In a sense. And then that's something that can be said that's I want that's very valid in workplaces, you know, across the board, right? Across many different fields, not just software engineering or industries. So, anyways, so let's see. The catch is that it won't keep us safe. Instead, it brings overthinking to the table. Sooner or later, decision fatigue, analysis paralysis, and burnout will also follow. So this is very true. You know, decision fatigue, analysis paralysis, and burnout are things that they're very real. I mean, I'm not sure, you know, and you have to be a developer or an engineer that has really put in the work to understand these things. You know, often working at the enterprise level, like I said, there's often nuances and politics involved. And so you'll kind of get a feel for this when you're constantly going to meetings, and sometimes you're having meetings about the same things, right? Um, Analysis paralysis, you know, you're constantly having to make decisions, right, about things that, you know, it's just like I said, it can be very stressful. Just that part of it alone. And then you also have the technical implementation portion of it, you know, which is on the software engineering perspective. And that comes with its own kind of, you know, stress. So now what do you do? So condition number zero is to identify when you're over planning. Be aware of the time spent on whiteboard daydreaming. You know it when you know it, then act. So time boxing. Make sure you time box your planning phase. Prototype. The solution is to prototype. Make it work. Identify the core features and produce a minimum viable product in a day or a week. With each iteration, you'll see more. Just like exploring a dark cave, the deeper you go, the more you see. You'll identify bottlenecks, challenges, problems, and solutions, gaining a comprehensive view of the project. So, this is very much my process. I mean, I go from idea to I want to say to MVP and you go from idea and then once you figure out your tech stack and then once you figure out your core features that you want to make this work, all that's left is to set up your project, set up your environment, you know, set up your directory folder structure because I architect all of my components out before I actually get started coding and then start coding your components. And if you're working with something like a front end, you can actually start seeing those changes, kind of happen live, on your local host. And you just kind of go from there and get it to MVP. With the front end project, it's usually very quick and very easy getting it to MVP, rapid proto. I mean, it's usually done in like I want to say an hour or two, depending on exactly how many components, how many pages, whether it's going to be done in HTML, CSS, JS, or it's going to be done using one of the front end frameworks such as re, React or Next, or whether it's going to be, where it's going to involve Tailwind, which is more involved, and it's going to involve, using a framework like Next.js. So it just depends on what exactly tech stack, I'm using, depending on how involved or how advanced the features might be, or stuff like that. If it's something really quick and it's a very simple front end website, I usually just draw it up really quickly with HTML, CSS, JS, and on something like CodePen. If you don't know what CodePen is, it's a web IDE where you can kind of very quickly, scratch up websites or work play around with JavaScript, stuff like that. Um, Maybe I'll make a video on that. But yeah, let's continue here and wrap this up. So keep in mind that this isn't an absolute solution. Systems closely aligned with the structured model, like implementing a white paper or an algorithm, may benefit more from planning. However, for the average CRUD system, the planning phase often proves to be nearly useless. So there's a personal account here. This person spent the last 3 years or so developing an end-to-end encrypted offline first, multi-platform, multilingual personal knowledge management platform or a system called YAD. They initially spent a lot of time in the planning phase and created countless architectures and diagrams, filling many papers and one PowerPoint slide after another. This was a hard lesson learned. I should have prototyped more, built more, and learned more by doing, not reading. Emphasis on this last uh, paragraph here. This was a hard lesson learned. This person said, I should have prototyped more, built more, and learned more by doing, not reading. There are many greater lessons learned in the process, but this one is the focus of this post. So, and there's a reference here to another article or YAD, which is the what this person was working on for years. So, big shout out to, like I said, Yekta.dev were the source of this article here. Very cool, very much in agreement with this. I'm so much in agreement with this that I actually started my own company, my own agency, which specializes in rapid prototyping. It's called Infinity MVP. You can check it out at infinitymvp.com. And if you're needing a solution, definitely give us a ring. And so I'll leave it there. Like I said, guys, don't just start coding, start building things. Especially, I would even, I'll make that a separate video. But that's it for this one. As always, keep coding, like the video, and subscribe to the channel if you want more coding content. Bye.